Alright, so, what? Anyways, the whole point here, again, coming back to this concept, is that today we're going to be looking at just two types of triangles. And why we call them special is because we had trig ratios for all the different angles, from 0 to 180. But the problem with trig ratios is we typically get these really long infinite decimals. It really does a lot of good. The nice thing about the special right triangles is that for a 30-60-90 and a 45-45-90, we can get very exact values without having to worry about dealing with trig. Okay, that's why a lot of the pitches on a roof are a 30-60-90 pitch. Because it makes it really easy to go in there, you automatically know what the relationships are going to be, without constantly having to go back and redo your trigonometry. How much trig have you guys done in building trades?
Just on the angle.
That's about it. So let's go ahead and take a look at our objectives for today. They're pretty simple. We're going to draw the model of a 30-60-90 and a 45-45-90, and then we're going to use them. That's pretty much it. We're going to learn what they are. We're going to draw the models nice and big so we can clearly see what they are on our notes. We don't lose them. All right, so here we go. First model is a 45-45-90. Sure, Sarah, whatever. It's your notes. Oh, you mean you want to borrow mine? Yeah, they're mostly dull. All right, so in a 45-45, what type of triangle is this?
Right.
Good, we know it's a right triangle. How do you know it's a right triangle?
Because it's a 90 degrees.
Yeah, we got the box that tells 90 degrees. Good, what else do we know, Corbin? It's isosceles. The base angles are the same. Therefore, it's an isosceles triangle. What does that tell you about the side lengths? They're also the same. So let's call those x and x. And if that's the case, this is what makes it a special situation. In a 45-45-90, my legs are the same length, but the hypotenuse, it's super easy. You don't have to do any, there's no thinking to this. This is the beauty of today's lesson. All you have to do is take whatever the leg is and multiply by root 2. It's that easy. Root 2. That's it. Take the leg, multiply by root 2.
So if the leg was 3.
Listen.
Feels that spring now.
No surprise. All right, so take a look at example 1, guys. I want to find my other two lengths. If my bottom side here is 8, what does that make for this side right here?
8.
Okay. What about for the hypotenuse?
8 root 2.
Okay. Take a look at number 2.
Be 3. The legs would be 3.
Why would the legs be 3?
Because you times the legs by root 2.
Yeah, if the hypotenuse is the leg times root 2, and that's 3 times root 2, what's being multiplied by root 2? 3. So it's 3, 3. Okay. Tough stuff. Then look at number 3. What shape do we have in number 3?
Square.
Okay. Well, what's my side length this time?
3 root 2.
3 root 2.
Be
So what's the bottom side?
3 root 2.
Okay, now be careful here. What's the hypotenuse?
6. No.
3 root 4.
No. That's
6.
yeah, 6.
6 or 3 root 4?
6. Because the square root of 4 is 2, and 3 times 2 is 6.
Okay, so 6 and 3 root 4 are equivalent. Well, we would write that as 6.
Okay.
Okay? So we know that the hypotenuse, x, is the side length, 3 root 2, times radical 2. And when you multiply radicals, you just multiply the insides. So that's 3 root 4. Root 4 is 2, so 3 times 2 is 6. Okay. The next one, I think, is where a lot of you guys' minds start having issues. What do we have this time? We have 18. It's a 45, 45, 90.
Root 2.
Is it 9 root 2?
Yes, it is 9 root 2. Now, I want to kind of talk to you guys how we get to that. We understand that the hypotenuse is the side length times root 2, correct? Okay, so what is our hypotenuse?
18.
So 18 is our side length times root 2. Okay, basic algebra. My pre-algebra students are doing this right now. What do we do to solve for x? Keep it simple. Divide by what? Divide by root 2. So x is 18 over radical 2. Is that an appropriate format to leave it in? Why not? Radicals cannot be on the bottom. So what do we do? Yeah, we're going to multiply by root 2 on top and on bottom. So that gives me 18 radical 2 all over what? All over 2, right? Because root 2 times root 2 is root 4. Radical 4 is 2. Okay, can I do anything with that now? Yeah, you can do 18 divided by 2, which is 9 radical 2. Ta-da! Killing me, Rachel. Absolutely killing me inside. Being a one out of student. I don't think we need to really do this part because it seems like you guys are getting this pretty good. Yeah.
Wait, explain one thing to me.
Yes.
Okay.
You get one
How
thing.
Did you get, okay. On number 4, it's 18 equals x square root 2.
Yep.
How do you get the 2? Yeah, so
Are you talking about where did I get to root 2?
yeah, like where did you get like all that from?
This part right here?
Yeah.
So it goes right back to the model. Go back to the original model.
So everything is just root 2.
Well, in a 45, 45, 90, the hypotenuse, Sarah, is the side length times radical 2.
Okay.
Alright? So number 4, your hypotenuse is 18.
Alright.
So 18 equals x radical 2. Okay?